Hello guys, how are you? We have question 10. It's an interesting question actually. It says, study the following circuits. If capacitor C2 is removed from the circuit 1 and connected in circuit 2 at point A, calculate the current through resistor R2 in the second circuit. So basically I'm going to bring C2 and put it right here. Okay, they want the current in the in the R3. They need the current in here. In order to find the current, guys, I know that current equals to potential difference over the resistance. Of course, I have the resistance. It is actually 2 plus 2, which is going to be 4 in this part right here, all of it. Okay. I only need the voltage. So the voltage in the series part, all this, the voltage, I will name it Vs, is going to be the same voltage V1, which is going to be the same voltage here of the capacitor. Okay, it's going to be the same voltage of the capacitor, because the capacitor will work as a power supply in the second circuit. Okay, so first of all, let's find the voltage of the capacitor C2. I need the voltage of the capacitor C2. Okay, now in order to find the voltage of the capacitor, I need to find the total charge. Okay, why is that? Because I need the voltage in here, okay, which I will name it V parallel. Here I will name it V1 in this circuit. Okay, first of all, I have the 3 microfarad and 3 microfarad. They are connected in parallel, which means that the C parallel is going to be 3 plus 3, it is 6 microfarad. Okay, now the C parallel and the C1 are series. Okay, so I can find the C total, which is going to be 1 over 6 plus 1 over 6. Okay, I will write it 1 over 6 plus 1 over 6 to the power negative 1 is going to be 3 microfarad, which is multiple 10 to the power negative 6 farad. I found the total capacitance. What I'm going to do with this total capacitance, I use it to find the total charge. Okay, so the total charge is going to be C multiple V. Okay, C is the total capacitance, which we found it 3 multiple 10 to the power negative 6 multiple the voltage of the battery, which is 6, and the answer is 18 multiple 10 to the power negative 6. Okay, this charge, of course here column, this charge, guys, is going to be the total charge for the parallel combination. Okay, the charge here is 18 multiple 10 to the power negative 6. Why is that? Because the parallel combination is connected in series with the battery. Okay, I hope it's clear. Now I can find the VP, the voltage in the parallel combination is going to be the Q over CP. Okay, Q, we just agreed it is 18 multiple 10 to the power negative 6, and the C parallel, we just found it right here, it is 6 microfarad, which is multiple 10 to the power negative 6, and the answer will be 3 volts. Okay, what is this 3 volts? 3 volts is actually the voltage in the C2 is going to be here 3 volts, which is the same voltage in the C3, 3 volts. Okay, which is also the V parallel. Okay, but we only care about this here. So we take this capacitance and we bring it right here. It means here this capacitor will work as a power supply of voltage 3 volt. Agreed? Agreed. Okay, good. Now pay attention right here, guys. Pay attention that the power supply is connected in parallel with R1 and connected in parallel with the combination of R2, R3, which means here is going to have 3 volt and here all of it is going to be 3 volt. Okay, it means this one right here, the voltage right here, is actually also 3 volts. It means I can find the current. Again, I will write the formula. V over R is going to be the voltage, we got it 3, and the resistance, it is 4. So the current will be 0.75 ampere. It's the current in the R2 and in the R3. Okay, because they are connected in series. As you can see here, we are repeating the properties of series connection and parallel connection. Okay, in capacitors and in resistors. I hope you know these information about the series and parallel. It will be easier to understand this question properly. That's it for question 10. If you have any question or comment, please leave it under the video. Have a nice day. Bye bye.